Hello, this is my spectrophotometer tutorial and chemistry video. I'm Peter Shen, and my other group members are Peter Shen and Peter Shen. So the first step is to transfer the solution that you're going to be measuring from a beaker into a cuvette, which can be put into a spectrophotometer and used for measurements. Do this using a pipette. Alright, here we have group member number 1, Peter Shen. He's transferring the solution from a beaker into a cuvette. You can see the precision he uses and the pipette skills at work here. Alright, he fills it almost exactly to the line. Here's a close-up. Beautiful. So when we got in the lab, the spectrophotometer was zeroed already by our awesome TA, so we didn't actually get a chance to record the zeroing of the absorbance using a blank cuvette. However, we do have a very realistic enactment of it. So you can see how we're in the chemistry building right now. We're just walking down the hall, and yep, that's room CH350. Yep, let's go in.
Alright, so we're in the lab and we're on the spectrophotometer right now, and the absorbance is like really high right now. Don't know what's up with it, but all we gotta do is insert that blank cuvette in and close the door, and then we'll press 0, and now the absorbance is where it should be at 0, and we can start testing our other samples.
So the next step is to take the dilutions you prepared and take absorbance measurements of them in the spectrophotometer across the entire visible light spectrum. And once you find lambda max, you can test only at lambda max to produce a nice calibration curve. So you can see a strapping young fellow here. He's just wiping down the cuvette so no fingerprints affect the absorption value of the sample. And he'll open the spectrophotometer. He'll place the two clean sides without fingerprints along the light beam. And next, he'll close the spectrophotometer so no outside environmental light affects the measurements. Next, he's going to go to his workstation and he'll try to open a new data file so he can save his data on a graph. It's taken him a while. Don't know why. And next, he'll just press test and it'll make a graph for him. And we want to show that the other group members can do this procedure as well. So here's group number 2 also taking a measurement. So here's a quick rundown of the qualitative versus quantitative information provided by a spectrophotometer. So first, you would usually scan across all wavelengths to find the most useful wavelength. And this would usually appear as a peak in the absorption versus wavelength graph. And this is the wavelength with the highest absorption, and it's also called the lambda max. So after you find this wavelength, the following dilutions would be scanned only at this wavelength to create a graph that models absorption versus concentration, also known as the calibration curve. So the Beer-Lambert law is A equals ellipson LC, where A is absorbance, or what portion of the light at a specific wavelength is absorbed by the sample. Ellipson is molar absorptivity, so it depends on it measures how well a chemical substance can absorb light, and it varies depending on the substance and the wavelength as well, and it's usually the slope of the calibration curve. L is the light path length, and in this case it would be the width of the cuvette in centimeters, where C is the concentration of the solution in molars. So molar is moles over liters. A lot of young budding amateur chemists are like, Peter, why do we have to zero the spectrophotometer properly? Well, this is what I tell them. Zeroing the machine allows the water sample to be at the 0 absorbance mark. So this would cancel the effect that water molecules and other substances might have on the absorbance. So your measurements would only measure the absorbance from the substance you want to test. Because believe it or not, water also bounces light around and absorbs a little tiny bit of it, so not all of it reaches the receptor. And this can vary your measurements by the slightest but noticeable amount. Here are my immensely interesting lab notebooks that I'm sure you're going to spend your whole day looking through word by word. With that, I'm going to wrap this up. I hope you have a great day, whoever is grading this.